Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Sandeep Sasikumar, who leads global sales for analytics and AI for Nokia. As a B2B technology innovation leader, Nokia pioneers networks that sense, think, and act by leveraging its work across mobile, fixed, and cloud networks. With truly open architectures that seamlessly integrate into any ecosystem, Nokia's high-performance networks create new opportunities for monetization and scale. Service providers, enterprises, and partners worldwide trust Nokia to deliver secure, reliable, and sustainable networks and work with them to create the digital services and applications of the future. Sandeep started his career in Bangalore working in R&D and product management before moving to the commercial side, leading alliances and sales for several startups. He founded his own company, an AI-based personalization startup serving mass consumer web applications. Sandeep also held roles in companies such as Comtel and Digital Intelligence. Sandeep joins us today as part of our exclusive editorial segment on generative AI for network management. Welcome, Sandeep. Great to have you on today's episode.
Thank you very much.
All right, awesome. So let's begin. How can CSPs leverage both traditional AI and its latest version, generative AI, to move towards fully autonomous network operations?
That's a great question. CSPs are on a journey towards fully autonomous networks, as you might be aware. So here, both traditional AI as well as generative AI may play a key role in making that happen. So traditional AI, as you know, has already been transformative, right? It has been helping in things like machine learning, has been helping with predictive maintenance, deep learning for understanding traffic and optimizing it. So we've been using AI in security analytics to understand, threats, things like that. So this has helped the network become smarter and more proactive. Now, while this is all great, right? These models are great at detecting patterns, predicting failures, optimizing resources, all of that. Generative AI makes us mark is in decision support, is in understanding things at a very large scale and then automating it. So now you can imagine a network which not only detects issues at a full network scale, but also generates fixes in real time, right? While explaining the problem in plain language for engineers to understand and generating documentation at the same time. So this is the power of GenAI. It can automate processes that were previously manual, would take weeks, write policies for self-optimizing networks, etc., and do this at a very large scale in real time. So a combination of traditional AI's predictive power with GenAI's ability to generate the knowledge and automate the processes, CSPs can actually accelerate their journey towards fully autonomous networks, which can self-heal, self-optimize, even self-secure with minimal human intervention.
So when we talk about Gen AI, we hear a lot about democratization of who can actually access the network, work with it, and make those decisions. What do you think about that?
So there is always this concern that who can touch my network, right? Who is allowed to touch my network? Do I fully trust an AI system to come and touch my network? This is a very valid concern, and I would think that given the maturity of a lot of systems, we are only able to automate things at in baby steps, right, as we go along. But as we can see, with using digital twins and other things, we are able to understand how fast we can ramp this up. Right. So if you know the TMF framework, you go from level 1 to level 5, right? Typically, most operators now are at level 2 or level 3. But we can see that level 4 or even level 5 is achievable in the next 3 to 5 years. And especially on the RAN, self-optimizing networks and, understanding customer behavior and making sure that they're getting the best experience for what they pay for, etc. These are areas where AI can actually make an impact in real time. So this is a place where we can actually start exposing the AI to start doing things. Now, there might be a little bit more sensitive things when it comes to business networks. You want to have more control over things, etc. Where we will take a little bit more time, but we will get there eventually, right? Because if you look towards the future, today you're seeing generative text coming from ChatGPT and all of those things. Tomorrow you will see generative applications. So that means these applications will change their nature overnight, which means the network also needs to change their nature overnight, right? So that will only happen when you give massive level access to the AI to change things and autonomy to the AI. This will not happen overnight. As I said, it takes time to build the trust, just like with humans. So we will also learn to trust AI in due time.
So if machines start making network decisions, right, do humans still have a role to play?
Yes, we have a role to play. I mean, the biggest power of humans have always been about creativity, right?
Yes, exactly.
And yeah, and that's never gonna go away. So humans will still imagine futures that AI can help achieve, right? So today we'll be looking at you'll be using AI to understand where are the issues in the network and why is that,
Yes,
and
yes.
vectorizing the network optimization handbook and things like that to make these decisions. But these handbooks and capabilities were actually created by humans, right? Now they will start to get expanded on by AI. But new business models, for instance, will be thought by humans, will be created by humans. New consumption models will be created by humans. So I would see an exciting future where the AI economy becomes like a very powerful tool in the hands of humans to increase the value literally overnight of what telcos are able to offer to their customers.
Amazing. So let's move on to a huge area of, I won't say concern, but it's very much talked about, which is data and how we're going to manage data moving forward, because data is
Yeah.
at the center of all the
Yeah.
AI, generative AI mechanisms. So then one question that we have here is, how important is domain specific data in all this? Because
Yeah.
we are using Gen AI for network management, so that domain, what are your thoughts on this?
So, my thoughts on this is very simple. It's absolutely critical, right? You've hit the nail on the head, right? Of any AI system, the effectiveness will actually depend on the data it is trained on, right? And in the telecom industries, you can't just take generic data sets and train it, right? Because each network has its own unique traffic patterns, performance metrics, failure conditions. So AI models will need to be trained on domain-specific data to be accurate and reliable. Let's take an example, right? So a generic AI model might recognize that latency is a problem. Oh, yeah, Tara
Yeah,
and,
yeah.
and Sandeep are not able to talk to each other because, the latency is not
Yes,
great, right?
yes,
But is it because there's a congestion, or is there a routing issue, or is this
yes.
because of a misconfiguration? So that only can be recognized if the AI is trained on that CSP specific network data, logs, and telemetry, right? Now, as we move into AI powered networks, right, completely as we said, autonomous AI powered networks, real time data becomes even more important, right?
Yep,
So
yep.
you need continuous, real time, high quality data feeds to create these accurate predictions and automate these decisions effectively. So without this, the AI driven automation that we are aiming for is simply not possible, right? So you need good quality data to start with, and then AI will take and generate more data to complement it, right? More domain specific data to complement it and start becoming more and more effective.
Yep. I think you pointed out the importance of data very well. So we just wanted to know something there, which is who assures the quality of data and who owns this data and manages and safeguards this data?
So today, data in telco is in silos, right? So you have customer care data sitting with one organization, which operates completely separately from the network organization, which owns the
Yes,
operational data,
yes.
right? And then you have somebody else having, digital data, which is for the digital platforms, all of that. Now, my observation has been in the industry that we try to solve this problem by creating big data lakes, right?
Okay.
Massive digital transformation projects to which last multiple years to kind of bring all this data together. But if I take an example, a North American CSP told me once that their 1 MB of data gets replicated to almost 1 GB
Oh, okay.
within the organization, right? So there's massive amount of replication, which means the total cost of ownership of the data has gone up significantly, right? So which one do you trust? There are many copies of the same data. What do you trust, right? What do you train
Exactly.
your algorithms on?
Exactly.
So the simple answer is very simple. The owners of the data, whoever owns that data, whoever generates that data, who's responsible for the data, that organization should be responsible for its own data, right? But then you need a very secure and a very, how do you say, foolproof system, a data mesh to actually expose this data to other organizations who need access to this data, right? Yeah, through APIs so that they don't get to mess with this data. So the data is secure. It stays in one place. It is a single source of truth. Many people can use it, but they do not create copies of which then you don't know who has. It's like a chain of custody,
Yep. Yep.
like evidence is concerned.
Awesome.
So yeah, that access has to be managed, and you need to keep tight control over that.
So it means that you will also be needing a lot of real-time data from the network, like you just
Yes.
pointed out. So do CSPs now have to invest in tools which allows them to collect more data points, more breadth of data, more depth of data? Is that one of the prerequisites before they start adopting GenAI and AI in a bigger way?
So as we said, baby steps, right? CSPs do collect data. The data that we collect has always been like, these performance management data, fault management data, especially when it comes to network operations, which are more aggregated data that we're dealing with, right? As we go into subscriber specific experiences and business models and things like that, you will need to start looking into massive volumes of other data, which is like, for instance, user experience data, right? User plane data, as we say, right? So that starts getting more and more complicated now because the performance metrics, etc., were aggregated. They were not very high volume. They were still volume, but they're not so
Yes,
much.
yes.
But now you start seeing massive amounts of user generated data coming in, which is a lot of data, right? And understanding and making sense of that in real time is a challenge.
Yep.
But where I would say Nokia and our peers is that this has been our bread and butter for the last decades, right? So we've been in that space. We're used to handling that kind of scale with reliability. So I would say that us and our peers are probably very well equipped to handle that kind of volume of data, right? Where the challenge is now taking that data and deciding what do you want to do with it in real time, right? Do you want to change the way your network works in real time? Do you want to go and create a new product in real time targeted towards a customer or a customer segment? So what do you want to do with this? So that's the big question. How do you want to monetize this capability that you've got at your tips? So that's the bigger question.
Absolutely. So we talked about domain-specific data. What about domain-specific AI techniques? Can you share some of those techniques?
Yeah, so telecom definitely is not like a one size fits all approach, right? So there are several techniques which are specifically designed for telco, like network optimization, automation, etc. So one of that is like federated learning, which allows CSPs to train AI models across multiple locations without moving sensitive customer data around. So as you can imagine, given our past conversation, it could be massive volumes of data involved. And when it comes to user generated data, there could be privacy concerns involved. Like, for
Yep.
instance, imagine an operator group based in France, right, which has assets in Middle East and which has got other groups' data in different countries, and they cannot have this data move borders, right? So how do you still train your models while keeping the data in the respective places? So that's that. Then there is reinforcement learning, and you must have heard a lot about that recently, right? With the decision
Yep.
support systems that have been that have been released, right? So reinforcement learning is pretty much like how humans and animals learn, right? It's basically reinforcing good behavior, right, over bad behavior.
Yes.
So think about it as a self-learning system that constantly optimizes network parameters based on the real-time feedback and to set network settings that improve performance on a continuous basis, right? So, and then of course, we've always even I think probably almost 10 years back started talking about anomaly detection, which helps detect and mitigate network security threats in real time or understand issues in the network in real time. So each of these techniques are going through their own cycles of evolution. Anomaly detection, it's been kind of overused in the industry to a large extent right now. But now we are seeing reinforcement learning and federated learning becoming more and more important. But I believe that for every problem, there is a unique solution, which is why there is a unique domain technique or domain expertise which needs to be deployed to have AI that works at scale.
Awesome. So we have data and then we have these techniques, right? So when you train your models and once you have trained it in a particular CSP environment, are you able to take the same model and bring it to other operators as well? Or do you have to, retrain, do a lot of fine tuning for every CSP that you guys deploy this with?
Yeah, yeah. It's a great question, right? So just like, every person's different, every CSP is different, right? Their customers are different, their markets are different, their networks are different, their vendors are different. There's a lot of things that are different. For example, the data that I will get in Verizon will be very different from the data I will have access to in T-Mobile, right? So my models still need to work, right? And the models still need to play its role. So which means that we need to have a system in which with the existing available data that is coming in, we can pick the right models, right? And we can tune the right models in real time based on the data that is coming in, which is best suited to serve the purpose for which we're deploying that model. Like, for example, if there is a particular model that's been working very well, but suddenly there is new data coming in and that model is no longer effective, we should be able to swap it in real time and bring another one in. So overall, we're looking at a framework which this is not all Nokia provided technology, right? So we are using hyperscaler technology as well.
Yep.
We are using things that comes from hyperscalers, other vendors as well. So we're using this in a combination to basically deploy a system where our domain expertise, along with the best-in-class tools from the industry, can work together to identify the best way to solve the problem in real time as the problem is being solved. So, which means that even if the data is different, even if the outcome has to be done a little bit differently, all of that, we still go in with a package that is 90% there. But then there is that remaining 10% of tuning and efficiency, which needs to happen as we deploy the solution.
Sounds brilliant. So, you talked about a little bit about Nokia earlier. So, tell us more about Nokia's solutions in generative AI in the space, and how do they support CSPs in deploying, managing, and scaling GenAI-powered automation?
Right. So, as far as Nokia is concerned, one of our key areas of focus is actually automated network insights and troubleshooting. So instead of engineers manually shifting through large volumes of logs and data, Gen AI can help generate these root causes, right? And even propose fixes in real time. So this is one big area where we are focusing in on. Another use case for us is customer support, right? So you can imagine, talking to a chatbot, right, or virtual assistants, which is answering questions, all of that. But can it also help engineers troubleshoot these issues faster by summarizing the network data and suggesting solutions in real time, right? So same technology which is used to interact with customers is also used to interact with the network and understand the problems and suggest solutions. Then there is policy generation and network simulation. So you typically have static policies that govern the network. Now the traditional models will predict network behavior if we change a policy and all of that. But together with Gen AI, we can actually quickly generate new policies and then test them on synthetic data before we deploy them, which means fewer disruptions and more efficient network management. And while we are here, we've always talked about zero-touch provisioning and self-optimizing networks. This is another big area where Gen AI can help us manage the usage patterns, the traffic loads, and security conditions. Without human intervention, they can automatically configure themselves, right? So they configure themselves. So not just Nokia, but even our leaders in the space, other leaders in the space, etc., are really leveraging Gen AI to make networks smarter, faster, and more autonomous. And I would say that this is something which has to be the norm, that anything that we build has to be AI driven, because what we are really building is a network for AI. And so if for you to actually develop something that at that scale, you really need a lot of focus on AI to do it. Does
Wow.
that make sense for you?
Yep, absolutely, absolutely. It
It's a
does.
fantastic time to be in telco AI, if you ask me, right? No,
Yes,
I really
yes.
love my work.
Awesome, awesome. So yeah, I guess because it's moving so fast, and before we have we had the time to digest Gen AI, we now have agentic AI as well, right?
Yes,
And
yes.
CSPs seem to be taking a lot of interest, and early implementations of agentic AI are everywhere, and some operators and some vendors are coming in to say that we had agentic AI all along, and then and it's
Yeah.
now being pushed in a major way. What are your thoughts on this?
So, agentic AI is mostly about decision support, right? And, this has been part of some solutions. I would say that it's been always existing in one way or the other, but the kind of algorithms, the kind of foundational models that we now have access to just improves our ability to create new use cases and deploy them very really quickly, much more better, right? So the big change is that the billions of dollars that have been invested by the large language model companies, the foundational model companies, are really starting to pay off, right? Now we'll talk about agentic AI today, and tomorrow we'll talk about AGI. And I know I'm in the Silicon Valley, and I hear AGI in almost every cafe that I'm walking into nowadays, right? And soon we'll talk about super intelligence, right? Things like that. So I would say this is moving on a dynamic pace, and we have to keep up with it, because as I said earlier, right, all of this AI has to work. It has to work on a network, right, which is not scaling probably as fast as the AI technologies themselves. So we have to use the same AI to actually automate the network and make it more and more autonomous, so that we can scale along with the speed of the maturity that these solutions are coming into.
Brilliant, brilliant. I think you've shared quite a lot today, and it's been a great conversation. Maybe we can continue this in one of those cafes in Silicon Valley moving forward.
Absolutely, Tara.
Okay, so I guess thank you, Sandeep. Thank you so much for your time, and for sharing all these insights, especially all the key topics, the model, the domain data, and also the domain techniques, which is something new that we learned today. So thank you for sharing all this.
Thank you very much, Tara.
All right, awesome. And to everyone tuning in, thank you guys for listening. If you want to learn more, visit www.nokia.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye-bye.